Okay, here we have a quick video to show you how to take out a GCF when you have only variables. So when you're taking out the GCF, you want to take out the greatest amount that they have in common. Okay, sometimes it helps to expand them so you could see exactly what we're talking about. X squared technically means x times x. And x to the fourth means y times y times y times y 4 times. And we have one z there, so it's times z. Okay, then the next part would be plus 1x, 4 y's again, 1, 2, 3, 4, and 2 z's. Okay, so now we want to look and see how many they have in common on each part of it. All right, so over here we have 2 x's, but this guy has only 1. So that means that we can only take out 1 x from each of them. Okay, so we're going to put an x over here. Then we're going to look at the y's. We have 1, 2, 3, 4 y's over here, and we have 1, 2, 3, 4 y's over here. So they can both afford to give us 4 y's, which means we're going to take out 4 y's, y to the 4th. Okay, just going to underline those. And then we have our z's. This guy has 2, but this guy only has 1. So that means they can only afford to give us 1 each. So that means we can take out 1 z. Okay, so this is telling me that I'm going to divide both pieces by x, y to the 4th, z, because that's our greatest common factor. That's what we're going to take out. So if I divide, that means I'm taking out an x, 1, 2, 3, 4 y's, and a z. And whatever I do to one part, I have to do to the other. Okay, now when you divide anything by itself, it's equal to 1, or it just cancels. So in this case, these are gone, 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 and gone. So what are we left with for this piece is just an x. And over here, x cancels with x, y, all gone, and z gone. The only thing we're left with is a z. So we factored out the greatest common factor. Okay, I'm going to show you an example without expanding it. Let's say we have a squared plus, nope, not plus yet. Hold on. A squared b to the 3rd c plus a to the 4th b c squared. Okay, let's look at it and see what they have in common. Say, sometimes I like to think about this as the exponents being money, right? Let's say these are you and your friends and you want to go to the movies. Well, this guy, these A, only have $2 to spend and this guy has 4. Well, we're not going to do something that costs more than $2 because this person only has $2. So we can only take out $2. So for this one, because there's 2 here and 4 here, we can only afford to give 2. So we'd be taking out a squared, which means we're going to be dividing both by a squared. Okay, and then we look at our b's. This person can afford 3, but this b can only afford 1. So we're not going to do something more than 1 because that would be rude. So we take out a b from each, which means we're dividing b. And lastly, we look at our c's. We have 1 c here and 2 c's here. Well, this guy can only afford 1, so that's all we can take out is 1. So we divide both. Okay, so this is our greatest common factor, but we have to do our division to see what we're left with. So a squared divided by a squared, well, those go away. B to the 3rd divided by b to the 1st. Well, when we divide variables, we just subtract the exponents. So 3 minus 1 is 2. So in that case, we're left with b2. C over c, gone. So we add, and what's left? Well, a to the 4th divided by a squared, we just subtract. 4 minus 2 is 2, so that's going to give us a2. Our b's cancel, and here c squared over c1 is just 2 minus 1, just gives us c. And we are done. I hope that helps.